All right, awesome. Hello, everyone. Welcome to my talk. The ACE is the place, or Stealthy Ldap domain reconnaissance. A little bit about myself. My name is Garrett Foster. I'm a senior security consultant on Optiv's attack and pen team. My primary roles on this team are to perform targeted internal and perimeter penetration tests, as well as recently to perform red team engagements with some light adult supervision. So for this talk, we're going to cover a quick high-level overview of what a security descriptor is in Active Directory and why they're valuable to attackers. And then we'll talk about BloodHound, kind of a well-known tool for performing recon of a target domain, and then kind of show the risks associated with running BloodHound when using it during evasive engagements. And then I'll introduce the tool I wrote, ACE, to alleviate some of those risks. And then following that, I'll show a quick demo of how that works. Okay, so the security descriptor is it's an attribute in Ldap that stores a compact binary representation of the security associated with a securable object. So essentially, it's a collection of data that identifies the ownership and permissions on that object. So it consists of four things. You've got the object owner, which is identified by a SID or security identifier. A SID is a unique value that identifies a trustee, such as a user or group, similar to how we all have a social security number. The primary group ID of the object, such as the domain users or domain computers group, which is also identified or referenced by a SID. Then you have the SACL, which is the system access control list. And the SACL provides administrators a way to audit a securable object. So anytime that the object is read, it will trigger an alert that will kind of give the administrator some more information. And then there's the DACL, or the Discretionary Access Control List, which is where we'll be focusing primarily. The DACL lists trustees that are denied or allowed access to a securable object. So each entry in this list are called access control entries, or ACEs. So ACEs themselves have several pieces of information. The first is the SID. So that's the specific trustee that has the right that we're going over. Then there's the access type, whether it's going to be access allowed or access denied. Then we've got the access mask. So what is the specific right that is being granted to the SID? Then we've got inheritance, which is whether the right is explicitly granted. So if it's just that individual account, or whether it's the group that it's a member of that's granting the right. And then you've got the object type, which I mentioned is sometimes. So object types, you'll find those in the ACE entry when you want to limit the right to something specific. So a good example of this is when you've got like a lower tier help desk group that you want to give them the right to change all of your users' passwords, but not give them the right, like, full control over all the users. So this is an example of what a DACL would look like if you were working from Active Directory users and computers. So on the left, you've got the different ACE types. So at the top, you'll see that there's an access deny, and then the rest are allow. Then you've got the SID, which identifies the principal that the right is assigned to, the access mask, and then inheritance. So for each row is an ACE. So why is Ldap and ACL Recon useful for attackers? The first being it identifies targets of interest in an environment such as like a user, group, OU, whatever it may be. So with red teaming, the target isn't always domain admin. We only need just enough access to reach the targets or the goal for the assessment. So and by analyzing ACLs, we can chain multiple abuses together and build attack paths to move laterally or to escalate privileges. So many red teamers, including some on my team, make a living bypassing endpoint protections. However, that's not in my wheelhouse, and I've found that the best way to avoid endpoint protection is just don't touch them. So let's live in Ldap. So the challenges in performing this recon is, there's a few. So in a perfect world, the flow of these ACLs would show you, if you looked up an object, it would tell you everywhere it has access, but that's just not the case. So it has an inbound flow. So when you're querying an object, you can only see all the rights against that one object. And then remember that the structure of the DACL is in binary form, so each piece needs to be translated to human readable format, which can be incredibly time consuming. So what's the solution here? Automation. So there's already several tools that exist that are really, really useful for this, and probably the most famous is SpectreOps' BloodHound. Now, for all the veteran red teamers listening, please bear with me while I go through this. When an attacker runs BloodHound, the entire domain is being extracted, every single object. And then it's being ingested into an interactive graphical interface. And then so it creates this big map of the domain, and it shows you how all those objects are connected and then the directional flows of those relationships. So in the screenshot on the right, that's an example of what BloodHound's graphical interface looks like. So you can see how each different icon represents a different object in the domain. So the green objects are the users, the yellows are the groups or OUs, and then the red icons, if you can see them, are computers. So, and then all of the chains connecting them are ACL relationships and how they might be abused. So this does solve our challenges. We were worried about that directional flow, and we wish we could see everything outbound. So now with a BloodHound, we can. And then it automates that translation. So now we've automated the SID translation, all of the different pieces of the ACE. And it's arguably the fastest and easiest way to map out a target environment. So while all of this is true, it really doesn't fit into the evasive nature of red team operations for several reasons. So BloodHound has been around for several years now, and defenders are very aware of its existence and have several opportunities to detect its activity. BloodHound and similar tools generate a tremendous amount of network traffic, which can trigger internal IDS and IPS solutions, especially if it's running over clear text Ldap, so it can just sniff everything in the clear. So, and then as the tool resolves hosts, if the requisite flags are enabled when running the tool, it will actually attempt to connect to each host that it resolves through DNS and try to identify session data, so if there's any logged in users at the time, as well as what users or principals might have local admin rights. And then previously I mentioned SACLs and how they can be used for auditing. So since BloodHound pulls data comprehensively, it's the entire domain, administrators can create accounts with an attached SACL. So the idea here is that these accounts should never be touched. They just sit there kind of doing nothing for a while. And then if the account is read, then that identifies that something might be nefarious in their environment. So another option, which is a little bit difficult to tune, is to enable expensive Ldap querying. And then essentially the idea here is that you identify thresholds for like common Ldap results. So Ldap queries happen all the time, but with BloodHound you're literally running thousands, tens of thousands of Ldap queries. So you can set a threshold that's unexpected, and then when that happens, you also know when something's up. So when do you run BloodHound during a red team? You don't. So while I was shadowing and learning the ropes, I noticed that things really started to slow down during domain reconnaissance. We have our own internal methods which are effective, but it was slower. And being the very impatient person that I am, I wanted something that would pick up the pace. I wanted to be able to resolve ACLs the same way BloodHound does, but with a little less shock and awe and a little more of a tactical approach. So I developed ACE. Some of the features with ACE are that it was designed primarily focused on being stealthy, which I'll describe a little bit more in the next slide. And then as you're running these queries, the DACL associated with the account is actually being parsed and returned to you in real time. So each principal that you query for is going to show up in your terminal. So while the tool is parsing the Ldap that you're querying for, or the DACL that you're querying for, it's actually logging the corresponding Ldap search in the background. So it's storing it in a text file. And then it has compatibility with a tool called BloodHound. And BloodHound is a tool developed by Fortalice, and it was created for transforming the logs generated by TrustedSec's Ldap search BOF into a BloodHound compatible format. So you could take all the logs that were generated during your operation, you're doing Ldap queries, and actually convert them to BloodHound compatible so you would have all the graphical fun that comes with it. So excuse me, so the logging that ACE performs is actually the same compatibility. So all those logs can then be transformed by BloodHound and then ingested into BloodHound. But with the BloodHound support, now you've got the opportunity for operators to ingest the queries that they're running with ACE, if multiple people are running it, and then actually be able to get the data shared between everyone. Okay, so a little bit about the stealth. ACE was designed to have a small network traffic footprint, only generating as many queries as needed to parse and resolve the DACL, and focuses only on those ACE types that we care about, which is the abusable ACE types. If it's not an abusable ACE, it just skips over it. ACE also supports Ldap over SSL, so your Recon traffic can be encrypted and kind of avoid those IDS and IPS solutions. It does no host enumeration. ACE only lives in Ldap and won't reach out and touch host to enumerate session or local admin data. And ACE focuses on resolving only one principal at a time rather than the entire domain, which provides a bit more control over what is and isn't being queried, which helps to reduce the risk of triggering those honey accounts SACLs. Then it has minimal Ldap queries. The longer your session lasts when running ACE, the fewer Ldap queries it needs to perform thanks to SID caching. So to identify what a SID is referencing, we need to resolve it with an Ldap query. Once a SID is resolved, it's cached. So the next time you run a query, ACE checks if this SID has already been resolved. If it exists, it's returned from the stored list instead of performing a query. So therefore, the more queries you run, the longer your SID cache and the more effective your searches are. Well-known RIDs are built in. A relative identifier is the last part of a SID, so like 500, 512, 513. Several objects are constant globally in Active Directory, such as the domain administrators group or enterprise admins, and they all share the same RID regardless of the domain. But since we already know this, we know the expected RID for these accounts, but there's no need to query for it. If the ACE applies to a specific object type, it contains the entire library for the Active Directory schema and how those object types are mapped to their specific GUID. So instead of having to do a query for that, we've got it stored, and we don't actually have to perform an Ldap query. So this is an example of the real-time DACL parsing. The top piece is going to be all of your specific object types that attackers might care about. And then the bottom are going to be your more generic and write. So these are like the access allowed lists, and these are the access allowed object types. The next is an example of what the Ldap search logging looks like. So after you actually look up an account, this is being logged into a text file in the background. And I mentioned previously, BloodHound was designed to work with trusted Ldap search BOF, and that's what you're seeing here. I know it's probably a little bit difficult to see in the back, so I'm sorry. But on the left is the Ldap search BOF running, and then on the right is BloodHound actually parsing those logs and then transforming them into BloodHound compatible format. And then this is a screenshot that shows the result of that parsing that data. So all of it is compatible with BloodHound. It's a very, very cool tool. Okay, so I will stop yammering and try to provide a bit of a demonstration. So for this simple demo, I'd like to kind of demonstrate what my envisioned workflow with ACE is. So we'll start from a low privilege user. I'm myself. I'm playing the role of an insider threat. My goal is to achieve domain administrator access. So the first query that I'm going to run is for the domain admins group. Okay, so you'll see here that both the DACL for the account was returned and resolved, and you can see that the domain admins and enterprise admins are all showing up. And then on the right, I'm actually tailing the log file so that you can view it in real time for each query that you run. So let's see if there's anything misconfigured over domain admins. So we're going to actually investigate the built-in administrators group, which is has a common misconfiguration, and sometimes users add principals to that and don't really understand the rights associated with it. So by actually investigating the log generated by ACE, we can look at the membership of the group and see that the expected group memberships are there, so the domain admins, enterprise admins, and so on. But we've actually got an outlier. There's Alfonso Cruz. So let's look into Alfonso Cruz's DACL and see if we can find anything misconfigured there. So the result is, over on the left is actually the parsed DACL for Alfonso. So we're going to look through it and see if we can find anything that kind of sticks out. If you look at the bottom, Herschel Becker actually has generic all rights. And generic all, there's plenty of abuse cases associated with that. So Herschel, we're going to investigate Herschel and see if there's anything we could abuse in that case. So by parsing Herschel's DACL, we can find that our account, Garrett, actually can change that user's password. So we have effectively created a chain that we can walk back from the domain admins group. Kind of a nuance with ACE is that if you want to be able to ingest it correctly, you have to have every object. So you query for the Garrett DACL, and then that'll get parsed out by BloodHound on the next slide. So once you've completed kind of your attack chain, you're done with the investigation, you'll transform it with Fortalice's BloodHound. You can see that it parses all 5 objects. We've got our users or groups, and then all of the ACL relationships. So once that data is complete, and you import it into BloodHound, now you can see the entire chain that we enumerated in real time into a graphical format that you can share with the rest of the team. So you can see the entire chain, both directions, and it's that familiar kind of BloodHound GUI that everyone knows and loves. So with ACE, you can stealthily pinpoint a target and then work your way backwards to build your potential attack paths and perform kind of like the domain recon while still being able to leverage all the features of BloodHound, and then so there's no need to manually parse the DACLs anymore. So that was it, but I do want to real quick have some acknowledgments. Dear Khan and Malema, I stole a lot of code from you. I thank you very much for all the inspiration. Adam Brown and Matt Krill, who were the developers of BloodHound, give them a follow. They have a lot of great content. And then my whole team at Optiv for putting up with me, constantly asking them to test out my tools. But that's it. Thanks. Any questions before I step down? Awesome. Thanks, everyone. Appreciate it.